Hey, Math 1 and Math 1 prep. Happy April Fool's Day. It's Wednesday, April 1st. Loading up another video for you to finish off the notes. Actually, it might be in a couple of parts. It seems like the shorter the videos are, the better they are to upload. So that's what I've been working on. You already have one uploaded onto your Canvas calendar. Here is the rest of the lesson. So we talked about the distance formula and midpoint and the Pythagorean theorem. A few other things that you need to know in this lesson are starting out with triangles, how to classify them by their sides and then by their angles. So if we take your regular old everyday triangle, 1, 2, 3, that shows all three sides are different. That's scalene, okay? A scalene triangle is no equal sides. Where isosceles has at least two equal sides. Okay, so two equal. I say at least because equilateral is also actually isosceles, but we're not going to get into all that stuff. So the equilateral triangle, that one is the one that has all three sides equal. Okay, so all sides equal. Believe it or not, that's also called equiangular because all the angles are equal. Okay, that's not listed in the next part, but I'm going to put it there anyway. The next part is triangles by angles. Okay, you have your everyday acute triangle. Okay, that all three angles are less than 90. All angles, that's how I make my angle symbol, are less than 90. An obtuse triangle, okay, that one, I'm going to mark it. You can see here, that's greater than 90. An obtuse triangle has an angle that is greater than 90. Okay, we're again with the acute. That is less than 90, less than 90, and less than 90 the way I drew it. And then, of course, your right triangle has that little box down here showing you that it's got an angle that equals 90. The other one I mentioned is just kind of a side one, equiangular. Okay, again, that's an equilateral triangle. And all three of these angles are 60. Because 60, 60, and 60 added up makes 180. Okay, so all angles equal. Now, if you can't tell by looking at it or on a graph grid, you can classify them using what we call the Pythagorean identity. I'm not sure you're going to have to really deal with this on your summative at all, but I at least want to tell you about it in case you see it. You can do the Pythagorean theorem. You'll see in this first box here. I'm looking at this right here. We have a right triangle. We have our c squared equals a squared plus b squared. If you plug in the a, the b, and the c, and they happen to be equal to each other on both sides, then that means the measure of the angle c is exactly 90. Okay, and triangle, we'll call it BCA, is a right triangle. Okay? Now notice in the second box here, same picture, it looks like a right triangle, but when we actually do the Pythagorean identity, the c squared ends up being less than the a squared plus the b squared. That means then angle C is less than 90. So that'll mean that triangle BCA is acute. Less than is acute. Equal is right. So then obviously this one you see the greater than sign. This means that triangle BCA is obtuse. Don't know why I wrote that in lowercase, but you know me. Okay? So that's called the Pythagorean identity. It's not hard. It's kind of a pain. In all honesty, I don't think you're going to have to use it on the summative. The only thing I would say is if you're asked to clarify a triangle by its side lengths or its angles, and you do the Pythagorean identity to find what kind of triangle it is, I would probably give you a 5 then. So the Pythagorean identity is more for you to earn bonus to get a 5 on your summative. Okay? Next part will be quadrilateral.